Let's talk now about some basic notation and how we write matrices and vectors. To start off with, a matrix with real valued entries, m rows and n columns, is written like this. We say A is in R to the m by m. This means A is a matrix with real values with m rows and n columns. Aij will denote the entry of the matrix in the ith row and the jth column. So first of all, we'll write A like this. It's a matrix where it has m rows and n columns. The ij entry then, this first one will be the 1, 1 entry, for example. It will be the entry in the first row and the first column. The next entry would be the 2, 1 entry, the entry in the second row and the first column. And similarly here we would have the 1, 2 entry. For the jth column and the ith row, this would be the ijth entry here. Now a vector is a special type of matrix that only has one column. So we're going to talk about column vectors. Those are vectors that have many rows and just one column. And we'll denote a vector with n entries as x being in R to the n. So here, there are n different entries in this vector, and really n different rows and one column. Similar to before, xi will denote the ith entry. So row I here, the element in that row, the ith element, will just be denoted as xi. Now one very important operation, which is so widely used that we'll introduce it right now, is the transpose operator. This is written as A superscript T. And this operator switches the rows and columns of a matrix. So in particular, for A transpose, the Ji element is just equal to the Aij element of A. If A is a matrix with n columns and m rows, then A transpose will be a matrix with m rows and n columns. Similarly for a vector, remember we're talking about vectors by default as being column vectors. That is, they are one column wide and have n rows. So if we want to talk about a row vector, a vector with only one row and many columns, we can write this as x transpose. This would equal a row vector with only one row and n different columns. Now it's often useful to write out the individual elements of a matrix in terms of its rows or in terms of its columns. So here we're writing out A in terms of its columns, not in terms of all its elements, but just the columns here, right? So A1 here denotes the first column of A. Now it's important to note that AI here corresponds itself to an entire vector. AI itself is a vector in Rm. This is in contrast to what we saw before, where the subscript I would denote an element in a vector. If we want to refer to a particular element in this vector, we're going to write AI with parentheses around it, subscript j. And by the way, this would be equal to AJI because it is the ith column. AI represents the ith column of this matrix, and the jth row. Now this might seem a little bit confusing because sometimes we use a subscript to talk about an index into a vector, and sometimes we're talking about an entire vector with a subscript. But you will just have to get used to that notation because you'll see it a lot, and people use things a lot like this in linear algebra. However, it should always be clear from the context we're using the vector or matrix in, whether it's an element or whether it's an entire column or row of a matrix. Finally, let's also write out the matrix A by rows. So here we write out the different rows of A, A1 transpose, A2 transpose, all the way to AM transpose, where here each AI is going to be a vector in Rn. And it's important we're writing the rows as transposes here, because by default, a vector is a column vector. So AI is actually a column vector with n elements. And so if we want to represent a row vector, the ith row of A, we have to transpose A. Now it's important to note that AI here is a vector in Rn. So for example, A1 would be a vector representing the first row of this matrix. This is different from the A1 we saw on the previous slide. On the previous slide, A1 was a vector that represented the first column of the matrix. And these are different vectors, right? A1 is a vector in Rn, and A1 on the previous slide was a vector in Rm. They aren't even the same size. And even if they are the same size, they can be referring to different vectors here. So it's important to keep all these considerations in mind. Typically, the type of vector and its precise definition should be clear from the context, but you'll have to become familiar with defining vectors and matrices in this way so that you intuitively know when you're talking about something like a column of a matrix versus an element in a vector and things like this.